Hi, my name's Kito, and this session is entitled Effective TypeScript. So the goal of this session is basically to give you a better understanding of some of the features of TypeScript so that you and your team can use it effectively. So just a little bit more about myself. I'm the principal consultant at Virtua, where I do training, consulting, mentoring with my team for a variety of technologies, including Java microservices, Jakarta EE, web components, Angular. So basically the gamut between front end and back end, and also some mobile as well. Basically whatever our clients need. My company, Virtua, is the official U.S. partner for PrimeTech, which develops a few open source products which you may have heard of, like PrimeNG, PrimeVue, PrimeFaces, PrimeReact. These are open source UI libraries, so we work hand in hand with them for those. I also wrote a book a long time ago called Java Server Faces in Action, which is, God, I think it was 2004 it came out, so a very long time ago. But that was the one book that I wrote. I'm the co-host of the Stack podcast, which is a podcast which I encourage you to check out if you like podcasts. It basically covers a variety of technology issues related to software development, enterprise software development, front end and back end, and just topics in general. We have guests occasionally, and we've got a few awesome co-hosts as well. So I encourage you to check it out at stackpodcast.com. I'm a Java champion. I'm a member of the Jakarta EE Ambassadors Leadership Council. I'm a Java Community Process member. All that isn't terribly relevant for this discussion, but I am a Google Developer Expert in Web Technologies, which is exactly related to this, because I'm a big believer in the power of the web browser and the power of standards as well. I also spoken at lots of conferences. So I'm pleased to be here at Connect.Tech. I've been here before at the actual Atlanta version of this conference, but I'm pleased to see to be a member of the virtual conference as well. So that's my story. I'd like to hear a little bit about you guys. Obviously, this is recorded, so if you please would just take a moment to just write a little bit about yourself or answer a couple questions in the chat. Basically, I just want to know if you consider yourself a JavaScript developer, if you have like a lot of experience with TypeScript or a little bit of experience with TypeScript, or you consider yourself a TypeScript expert. And if you're using, like, what front-end framework are you using? Are you using Angular, React, Vue, or something completely different? So I'll give you just a minute to put those in the chat, just so we can get a handle on where everybody's coming from. Okay, awesome. So this session is pretty much designed for a few different sets of people. So pretty much anybody who's worked on maybe one or two TypeScript projects, and you were writing TypeScript but you weren't really paying a lot of attention to it, and you want to get a better handle on how you can make more efficient use of the language. If you're new to TypeScript, this will be useful to you as well. Although I'm not going to do too much intro stuff, but I think if you're familiar with JavaScript, the TypeScript stuff should be useful to you, and I think you'll have a good handle on sort of what I'm covering. And of course, if you're leading a team that's working on a TypeScript project, this might give you a handle on some things you can do with your team to try and make them more efficient. Okay, so why TypeScript? First of all, of course, if you're at this conference, you probably like JavaScript, or at least you've worked with it a lot. So it's a pretty cool language. Has lots of great features, especially the last few years. I feel like it's gotten some really, really powerful features. But it's a little bit flawed. And if you think JavaScript is perfect, you probably need to look a little more at some of the underlying initial design decisions. Initially, I think it was a little bit of a messy language, especially if you look at it before, say, ES5. So it's ridiculously flexible. It's ubiquitous, of course, but sort of Sorry, my slides went backwards there. But I think we all can agree that there are some rough edges. Okay, and one of the things that TypeScript does is it tries to smooth out those edges a bit. Okay, and the main goal of it is to provide you the flexibility and power of TypeScript, but giving you a little more confidence that your code will scale and that it is less likely to have errors at runtime. TypeScript is open source. It was started and it's maintained by Microsoft. And the lead architect is Anders Hallberg. And what's fascinating about him is that he is the lead architect behind Turbo Pascal, sorry for the misspelling there, Delphi, and C#. And I personally, like, Turbo Pascal is my first language. And then I also went on to use Delphi. I never got super into C# because by that time I was really into Java. But I think it's sort of ironic that I sort of found myself back working with another Hallberg language. so this Anders is a brilliant guy, and his languages are truly a great product. So I think it's not surprising that TypeScript is such an excellent tool, and that it's done so well in the marketplace. So basically, you can think of TypeScript as essentially a transpiler with a whole bunch of extra features. So it supports all the latest JavaScript features. You can think of it like Babel, Tracer, or Clojure, and even Babel will compile TypeScript now. So you can even do TypeScript with Babel without the TSC compiler if you need to. But on top of all the latest JavaScript features and some other sort of language, syntactic sugar and things like that, it also has an extensive type system. And the key about the type system is that it was meant to work in the world of JavaScript. So it was designed so that it could describe existing JavaScript code just as much as it was designed to write new TypeScript code. So because of the type system, you get code completion, refactoring, and other features that were used to in statically typed languages. And the main thing is that it reduces errors at runtime. Okay, that's what we all want, is for our code to be sort of rock solid. So there's not a lot of excuse my timer there, a lot of unexpected issues. So since TypeScript is a transpiler, it outputs JavaScript. It can target different runtime environments, so it can target ES3 or higher. Typically, you're going to be targeting ES5 or ES6 at a minimum, and you can even go all the way to ES.NEXT, which is essentially the latest, greatest features of JavaScript. And the type system itself doesn't affect the runtime. So even though like the compiler may complain about stuff, at runtime, it's all just JavaScript. Okay, so a lot of what TypeScript does is basically compile time type checking. So the number one thing I want to emphasize is that to effectively use TypeScript, you really need to just use as many of the cool new JavaScript features as makes sense for you. So of course you're going to want to use class syntax, let and const, arrow functions, modules. ES6 modules I think are great, so if you can use those, I highly recommend them, especially for prototyping and development. Of course, you can use async await, generators, iterators, maps and sets, proxying and reflection, internationalization and localization. And some of these other things I don't see in the wild as much, like use of maps and sets, proxying, internationalization, localization. So I encourage you, before you pick up a third-party library to do these sorts of things, that you just look and see what's built into JavaScript, because there's a lot of stuff there. So one of the features that's been in TypeScript for a long time and has now made its way into other transpilers like Babel, etc., are decorators. These are not yet part of the JavaScript standard, but they are on track to become one. They are a TC39 is the working group for TypeScript, so for JavaScript, excuse me. So there is a proposal for decorators out there that's been iterated on quite a bit. But TypeScript has had them for a long time now. So here's a very simple example, and if you've written Angular code, I'm sure you're an expert with this. But essentially, this is actually an example of a Polymer component. Polymer was a framework which has been sort of superseded by Lit Element for writing web components. But essentially, you can decorate a class or a property or a method. Let's see. And basically what this is doing, it's saying at runtime, I want to provide some additional behavior. I want to basically decorate what happens with this particular declaration. Okay. So in this example, we're basically saying this is a web component, and we're specifying these as web component properties. And you notice a decorator can have its own parameters sent in. Okay. And then at runtime, certain things are going to happen. So because this is decorated, at runtime, this is going to be recognized as a web component with properties with certain types. The properties are mapped to attributes on the web component element. And this is an interesting feature that Polymer had called observables, or observers, excuse me. It's not the same as RxJS observables. But basically, this would basically say whenever this property changes, call this method. And this is another decorator for a listener to say whenever this particular event is executed, to call this method as well. So decorators are pretty cool. You find them in a lot of frameworks these days. And it turns out really all they are functions. So this is the component decorator. And basically all it does is it takes the tag name and the extends tag. So these are the parameters that you can send in. And then it just basically adds is to the prototype. And if the extends tag is there, it adds that as well. So basically it's just doing some extra work for you. So all decorators do is they basically take your class and do some extra stuff for you to keep you from usually doing repetitive things or complicated things. Here's another decorator. This is a listen decorator. So basically you can see it takes an event name and then it basically returns a new function that sets up the listeners on the target, etc. So basically it's doing some additional making additional changes to the actual target as well, and adding additional listeners for that particular event. Okay, so that's something that I think a lot of people have seen. There's a couple newer ES.NEXT features I want to discuss, and these are available in TypeScript and other transpilers as well, and also in a lot of browsers, most browsers now as well. They're a stage 4, I believe, in the TS39 or TC39 spec process. So the first two I want to discuss are optional chaining. I can never say this, and nullish coalescing. Okay. So let's take a quick look at these. All right. So you can see here, I've got a leaf, and a leaf is just an object that has a color. Okay. And you'll notice this public syntax here. So this is a TypeScript feature where basically this is saying, because I'm putting this in the constructor and giving it the modifier public, essentially this is going to be a property. So this is shorthand for this. So it's shorthand for this. It just keeps you from having to declare it. And unlike JavaScript, if you want to have a property on an object, you actually have to declare it. So I can't just do this. That won't work, and it don't work because property foo does not exist on type leaf. Okay. All right. So got my leaf. I have a tree. And I'm basically saying this tree takes rest parameters, so it can take X number of leaf objects. And all it's doing is basically creating a copy of that array and setting that as the leaves property. So that's pretty straightforward. And then I create a new tree that has a whole bunch of leaves. And you notice one of these leaves has a null value. So if I'm going to iterate through all of the leaves, if I want to account for the fact that one of these might be null, instead of having to do if this is null, then do this, and all that kind of sort of boilerplate code, I can just use the optional chaining operator and basically say that, okay, if this doesn't actually exist, then just return undefined. Don't blow up, but basically just don't do that work. And I can combine this. Well, actually, let me just take this off here, and I'm going to use this great plugin I found called Quokka, which gives me some extra analysis here. So basically, what's going to happen is this is going to do RGB and then undefined, because when it gets to the value that's null, it's just going to throw in undefined instead, because I'm using this. If I didn't do this, I actually get a runtime error. Okay, so it's pretty handy. But what's nice is if I use the nullist coalescence operator, I can do this. So I can say if this is undefined or null, just return this empty string. Okay, so it's very handy, and honestly, this is one of my favorite new JavaScript features. I wish every language had this. I was glad when they added it to the Angular expression stuff as well. So it's pretty similar. The nullist coalescence operator, which I still can't have a hard time saying apparently, is very similar to the logical OR. So you can see here I can say any, if this is null, right, or foo, I return foo. The difference is that the logical OR works with falsy stuff. So I may not want this to work for 0 or an empty string, which is what's happening, because here it's saying if this string is empty, then return this. So what's nice is that the nullist coalescence operator actually works with, actually only looks at null and undefined. So here, if I pick 0, it's going to pick 0 because it's not null or undefined. Now if this is null, it would return foo. Same thing goes for the empty string as well. So empty string, according to the nullist coalescence operator, is actually a valid value. So it's one of the great new features. All right, so let me go back to the slides here. Okay. Another new feature in JavaScript are private properties, which we'll talk about in a little bit. So those are pretty nice as well. So TypeScript has all the normal JavaScript types. Essentially, it's more of a superset of JavaScript, so it doesn't really take anything away. Well, unless you turn on some flags, but by default, all the same types are still there. Okay. And as we know, in JavaScript, you can pretty much reassign a variable to anything, right? So a variable can be reassigned to any primitive or an object. Okay. So we have a simple declaration where we set a to 1. We can also set a to foo. We can also set a to some other object. It doesn't matter because a is always good. TypeScript is a little bit different. Every variable has a type, and that type can be inferred. Okay, and type inference is a really great feature of it. And rules govern which types can be assigned to each other. So you can't just assign any arbitrary type to another arbitrary type. There are rules that define what can be assigned. It also fully supports generics, which really help it describe sort of the rich world of JavaScript. So let's look at some basic usage here. All right, so over here I have a basic usage class. or file, I should say. Okay. So one of the things you'll notice first is that we have an interface, right? So with TypeScript, you can have a very classical OO style of programming if you want to, but if you want to do purely functional, you can as well. It does not discriminate, but it does give you the ability to have an interface and abstract classes, okay, and all the things you're sort of used to having, like, you know, default parameters, things like that. Also, you'll note here that you can use all of your usual things like template literals, etc. Okay. So I have an interface animal. I have an abstract base class that implements animal, and then I have a person, okay, that extends base animal. And we notice a couple things here. First, we have a read-only. Okay. So there are different modifiers. I can do read-only, which means that if I do this, so I want to do a person equals new person. I'll be narcissistic and put my name here, about 6 feet tall. Okay. I can do p dot first name and change to something else, right? Oh, no, I can't because I made it read-only, right? So this is, again, a compile time check. So I can do modifiers like that. I could also make it private. I could make it public, of course, which would be like a normal property. Okay. And also, I said that types can be inferred, so I don't really have to do this. I could really honestly just do this. And now, if I look at this type, TypeScript will consider it a person. Okay. So that's the way that works. Excuse me, I don't know what's going on with my nose today. It's like super itchy. All right, so that's the story there. Also, you see this class has a private field, right? So if I did p.height equals 5, that's not going to work because it's private, right? Now, this is the TypeScript version of private, which has been around for a while. There is now a JavaScript version of private, which looks like this. So if I just made all these height, okay, I can do this, right? Oh yeah, it's read only. Okay, I can't do that. But if I wanted to do this, right, I can't do this either, okay? Because height is not accessible outside the class person because it has a private identifier. So so you can do private properties either way. They're a little bit different in terms of how they work. So I encourage you to take a closer look and decide which one you like better. The TypeScript version is erased at runtime, whereas the JavaScript version is not. And also you need to make sure that your runtime, which means the browser and Node.js, supports the new JavaScript version. So a couple other things I want to say here is that this project has a tsconfig.json file, and this is essentially where you define all the information about your project. Okay, and there's a ton of things you can do with this file, but at a minimum, you want to do a few things here. You want to make sure that you set no emit on error, so that when TypeScript runs into an error, it will not output other files, and I think that's very important for debugging. Otherwise, you end up in situations where there's a bug in your code and you didn't realize it wasn't transpiled properly. Strict we'll talk about in a little bit, and then you want to specify the targets and what modules are available. I'm sorry, what module loader or module type you want to support. It supports a variety of types, which is handy. And the important thing to point out is that if we do this, let's see, I think this. So you can have multiple tsconfig files. You can have they can also extend each other. So it's a pretty powerful way to handle things. All right, so this found a couple errors in my structural typing example. So let me just comment these out. Okay, I found one more error in my structural typing, which is right here. Okay. So what we're going to get here are all of the JavaScript output for these. Okay, and this is going to be targeted for whatever environment we chose. And if you look here at his basic usage, you notice it looks pretty similar to what we had. Okay. Okay. So this part is similar, right? But you notice here on the right, we have the base animal. The interface is erased. Okay. But we do have the base animal, and it's not abstract. It's just a class because there's no abstract classes. All this looks pretty much the same, except we notice the types themselves are gone. Okay. And also you'll notice in this example that this is a slightly different one, but we don't have to declare the properties up front, which you don't have to do in JavaScript. So that's the deal there. All right, so let's go back to the slides. So TypeScript has normal types like you're used to, like null and defined, and undefined, excuse me. It also has this type called any, and any is essentially what you're used to having in JavaScript. Basically, the type that you can basically use for anything. So in this example here, we have let foo any, which is exactly the same as just declaring a variable in TypeScript, in JavaScript, excuse me. So basically, you can very easily just change. You can, declare a variable and then set it to anything you want. In TypeScript, though, if you specify the type as something other than any, TypeScript expects it to have the things that you're calling on it. So you can't call toFixed on an object because it's not there. It doesn't exist. So any is essentially the default type that we use in JavaScript. And a lot of what TypeScript is about is narrowing that to something that's more like what you're actually using. There's also a void return type, which of course is what happens if your function is not returning a value. There's a never type, which is kind of interesting. Basically, your function can return never if you know that it's not going to return a value. So in these examples, it's like throwing an error or something, or it's an infinite loop. So it's basically just a way to tell the compiler, hey, this thing is never going to return, do not expect a value. All right, so I have a demo of unknown, which is another type, so I'll just jump to that real quick. All right, so we'll go to the TypeScript version. Okay, so here's an example. I have an interface called message holder, which has a message, and I'm going to turn on my cool plugin here, Quokka. So message holder, just a class that has a message. Okay, and then I'm going to basically have a function that has a type that takes a parameter that's a type of unknown. Okay, and basically what I'm going to do is do some work with this parameter based on its actual type. And this is essentially what we call using type guards, which is what these are, and then narrowing the type. And the thing about unknown is that I'm not allowed to do anything on it unless I've actually narrowed the type. So for example, if I did x.message here, it's not going to work because we don't know what type it is. However, down here, I know that an error has a message property, so I'm allowed to do it here. And also, you'll see the compiler will tell me what other things I can do with an error. Up here, if the type is a string or a number, I can do anything that's related to both a string and a number, which is to locale string, to string, and value of. So those are the only operations I can perform. So this is one of the powerful features of TypeScript, is the ability to have type guards and narrow the type. And also unknown is kind of a nice way to sort of force you to figure out the type before you do anything. Because if I made this any, I could just do, x.foo_bar_baz, right? And it would work. But if I do unknown, I have to actually narrow the type. Another thing you'll see here, this is a type assertion. Okay, so basically one of the things you can do with TypeScript is you can cheat and say, I know this is whatever type I think it is, so just let me treat it like one of those. So because I'm doing a type assertion, which is sort of like a cast for this parameter, I can only access message, right? And even if this was something else at runtime, it would actually fail. So if I did, F20, something like this, this would actually fail. So, all right, we'll do that. Okay. So we get undefined. It doesn't actually fail. And we get undefined because this x.message is undefined. So that's what's happening there. All right, so let's go back to the slides. So another powerful type is enum, which essentially, oh, hey, I lost myself here. Let me put myself back. There we go. Hi. So enum is like an enum in any other language. Basically, it's a constrained set of values which can have some other value. They have a name and some other value. So by default, it would be like 0, 1, 2, 3, whatever. Here I've assigned right to be a certain value, and then I can of course do a switch statement on it, etc. You can also use enums with strings as well, which is pretty handy if you've got like a set of strings that you want to put in a single place. A tuple is essentially the ability to have a type that has a couple repeating types. Okay, so here a tuple can be a string and a number, and if I want to add other values to it, they have to be a string or a number, essentially. So it's sort of just a way to say, okay, I want to have a couple different values in my array. There's also an intersection type, which is kind of cool, and the idea there is it's just basically the intersection of the properties and methods in a particular, or functions I should say, in a particular type. There's also union types, and these ones are really handy in situations, especially when you have a string and you want to constrain the string value. So here I have a pad left where I'm taking two different values, hello there, and then the amount that you want to pad. It will do something different depending on whether or not it's a string or a number, using those type guards that we discussed earlier. But also I can have a union type where I'm basically just constraining a string to a particular value. And what's nice here is that if someone were to try and set style to something else, it wouldn't work. It has to be accordion, collapse, or normal. So it's sort of like an enum, but it's basically just saying it has to be one of these things. There's also index types where you can say this type must be a property of another type. Okay, so key of person must be name or age. And this little pluck method here, which you see uses generics, actually will just basically pick whatever property we select and then provide that value back. Okay, and it will you can only pass in something which is an actual key of this. So you can't pass in some arbitrary string. It has to be key of that object. There's also conditional types where you can essentially take a type name and then you can basically conditionally return another type, which is kind of a powerful thing. And this sort of ability where you can take something like this, and I think down here I've got an example. So because we have this type T4, okay, and it takes the type name of a string, it has to be an object. Okay, so if I try to assign it to something else, I'll get an error. Okay. So the ability to do things like that with the TypeScript type system has given rise to a whole bunch of utility types. So there's partial, read-only, record, omit, exclude, etc. There's also parameters, instance type, this parameter type, tons of these things. So I encourage you, the more you work with the language, to sort of take a step back and look at the utility types and see how they can make your life easier. They usually will do really cool things, like pluck out certain properties of a different type. They're pretty powerful, so I encourage you to take a look. So the TypeScript type system is what we call a structural type system, and essentially what that means is that it looks at things based on the shape. Okay, as we said, everything's transpiled to JavaScript, and it's also considered unsound, which means that there are situations you can get into where the types are not actually enforced. So the basic rule is that X is compatible with Y if X has at least the same members as Y. That's the basic idea. And I'll show one last demo here. Okay, so let's look at structural typing. Okay, so we've got this weight interface, which basically says any object that has a property called weight is a weight. Okay, and I'm also I'm declaring something to be weighted. I'm also creating just an arbitrary JavaScript object with a name and a weight. Okay, and I can very easily assign weighted to equal weighted object because weighted weighted object is essentially a subtype. It actually matches because it has this particular number. Okay. However, if I assign it the other way, I get an error because weighted object has two properties. It has name and weight, whereas something that's weighted only has one property. Okay, so the error I get back says property name is missing, but it's required type. So in this example, I've got a widget. Okay, the widget takes a name, weight, and a color as properties in the constructor, and the same rules apply. So if I have this weight, right, and I have my weighted, and I can do a weighted thing equals a widget because it has that weight property. But if I do it the other way around, I get an error. Okay. So basically, the idea here is that regardless of whether or not it's actually a class that you've created or an object, TypeScript is going to look at it based on its shape. And you'll see here, if I have this widget packager where I pass in a widget, I can pass in an actual widget object or anything that matches that shape. But of course, I cannot pack in a weighted because a weighted is missing two of those properties. Okay. And of course, I can use type assertions to essentially cast something to a different type as well. Okay. Okay. All right, so let me just wrap up here. A few things I want to point out is that you should use TypeScript with external libraries. So if you're using it in your project, but you're not using it for typing external libraries, you're kind of missing out because that's a big a portion of its appeal. It's basically the idea that you can reference existing libraries using actual types. And the main benefit of that, really honestly, well, one of the main benefits is actual code completion. It's like you don't have to look up what the names of the properties and methods are. You can just get code completion from the IDE. But also you get compile time safety as well. So that's one of the main things. And you can get the TypeScript libraries pretty easily from this site, which will let you search for different, whoops, not sure what just happened there. Oh boy, let me go back to this. Okay. Yeah, that was a bit of a bad link there, but essentially you can go and do a search for any library you want and see basically if they have TypeScript definitions for them. And pretty much every library at this point either has definitions available or includes them in the default package that you get for the project. So just do a check there. If they don't have the types in the package that you're using by default, you can usually install them just by doing something like this: npm install save types / whatever. If you can't find typings for it, you can honestly just create your own. Obviously, doing so thoroughly is a lot of work, but you could do something very simple, like just creating a .d.ts file and then just say this is my library and calling it any, and then you can reference it, because TypeScript is not going to let you reference an object that it doesn't know about. So you have to at least tell it what it is. As we said earlier, use tsconfig.json. You can specify most of the command compiler options or all of them online on the command line, but you're usually better off using your tsconfig.json file, and it has lots of great features in it. It's really well documented now, so I encourage you to see sort of what you can do with it. Okay, so I said there's a few recommended options. Experimental decorators is one. You want to specify the target environment. You want to say no emit on error, which I think is important for avoiding issues later on. And then you want to use strict. And strict is a really powerful feature, and it really does sort of force you to always do things in a very type-safe manner. So there's no implicit any, which requires you to declare something to be any. So you can't take a parameter without saying it has to be any. No implicit this, which avoids a lot of the this errors. Usually it's not that important if you're using arrow functions, but it's useful anyways. Always strict means you're always in the browser or the JavaScript strict mode, which is pretty much something you need to do regardless, right? And it will happen by default if you use a module. Then there's strict bind call apply, which allows you to avoid calling bind or call or apply and sitting in parameters which don't actually exist. There's strict null checks, which keeps you from getting in situations where something might be null. Strict function types, which makes it safer when sitting in parameters into a function. And then strict property initialization, which sort of means that if you're declaring a property, you have to initialize it up front, or at least if you want it to be null or undefined, you have to say it can be null or undefined. So I encourage you to try and use all of these features. If you can only use some of them, that's fine, especially if you have an existing code base, but I would encourage you to try and use as many as possible. All right, we don't have time for a demo. All right, so the bottom line is that effective TypeScript requires understanding new JavaScript features and also being able to spell understanding. It requires understanding the way the type system works in TypeScript, and of course effectively using tsconfig.json. I encourage you to make your project as strict as possible. And of course you want to make sure you import typings for third-party libraries. All right, so here's a few links. TypeScriptlang.org. There's a really great book out there, bassarat.books.io. You can reach me on Twitter at Kito99, and you can also check out my company at virtua.tech. Thank you.